So welcome back. In this session, we demonstrate how to draw a divided difference table. So I've been given some values of x and some values of the function. So this will form our x naught. This will be our x1. This will be our x2, x3, and then this will be our x4. So this will be f naught, f1, f2, f3, and f4. Remember, by definition, f sub k means the value of the function at xk. So f naught simply means the value of the function at x naught. F1 means the value of the function at x1 etc. So to draw a divided difference table, we'll have a table of values for x and the function f. And like in the case of the finite differences, we'll now be leaving two lines for consecutive values where we'll be defining the quotients. So I'll write x in this column, and then f of x. So the first value of x is 5, whose corresponding value to the function is 150. Skip two lines and write next value is 7. Value is 392. Skip two lines, 11, and then 1452. Skip two lines, write 13. And then the value at 13 is 2366. Skip two lines and write 21. Value is 9702. So we are skipping two lines so that we can have enough space to define the quotients. So this is what we define the first divided difference of the function. Now, at this point, to define the first divided difference will be 150 minus 392 divided by 5 minus 7. And when you work out this one, you should get the difference. And once you get the difference and you divide, you will get 121. This other space will be now 392 minus 1452 divided by 7 minus 11. And when you work out this, you get 265. Next will be 1452 minus 2366 divided by 11 minus 13, which will give you 457. Then lastly, the first divided difference will be 2366 minus 9702, or divide by 13 minus 21. And when you work out this, you get 917 as your solution. So this is the first divided difference. Next is the second divided difference of the function f of x. So now to define the second divided differences, we are going to use the values we have in the first divided difference, but then the denominators will be taking care of the values of xi's. So this first one will be 121 minus 265. And then for 121, the lower value here for x was 5, so it will be 5 minus this value here is 11. When you work out this, you get 24. Next will be 265 minus 457. And then for 265, the lower number is 7. For 457, the upper number is 13. So when you work out this, you get 32. For this other difference will be 452, 57 minus 917 divided by, for 457, lower number is 11. For 917, the upper number is 21. When you work out this, you get 46. So that is how we define the second divided differences. Now, lastly, to define the third divided differences of the function f of x. So remember this, we write this as will be 24 minus 32. Now for 24, the lower number is 5. For 32, which is the upper number is 13. So we'll have 1. Next will be 32 minus 46. For 32, lower value in the denominator is 7. For 46 is 21. So this will also give us 1. And then, so because we have two numbers, we can as well define the fourth divided difference. So which will be given by 1 minus 1. For this one, lower number is 5, upper number is 21. But this will be 0 because the numerator will be 0. So that is how we draw a divided difference table for those values given in this table at this point. Thank you.